Hi, welcome to the Unit 2.2a Solutions Chemistry video. This is part one of a four-part video. So let's get started. In Unit 2, we are focusing on chemical reactions, specifically chemical reactions that occur in solution. And there are two types. There are precipitate reactions, which are shown here. So notice you have a solution of two salts. They're both aqueous at this moment. You can tell that they are well dissolved in the water, but then when you mix them together they form a salt that does not dissolve. It precipitates out of the solution, and so that's where this solid comes in. For neutralization, we mix an acid and a base together, and that will form a salt in the water. So at the top you're gonna have to change this on your handout, but just say reactions of acids and bases. I just want to start by reviewing some of the terminology we learned. We learned the Bronsted-Lowry acids are proton donors and Bronsted-Lowry bases are proton acceptors. So let's take a look at a reaction and see where that's coming from. Here we have HCl, which is an acid. We recognize it's an acid because it has a hydrogen in front. And NaOH, which is a base because it's a metal hydroxide. All right, so the hydrogen on the acid, that proton, that H+, will go with the OH, or the hydroxide group, on the sodium hydroxide. And that forms HOH, which is actually H2O, or water. The other thing that it forms is the Cl- and the Na+1. They will get together and form NaCl. So as you can see, the acid donates its proton to the base, and the base accepts the proton from the acid to form water, and then the other product would be salt. The reason why acid-base reactions are called neutralization reactions is because acids have a pH that's less than 7 and bases have a pH that's greater than 7. However, when you mix them together, they start to, the pH of the resulting solution will be in the neutral zone, which is around 7. So you're missing something that has a low pH with something with a high pH. It sort of like averages out in the middle. It's not exactly averaging, but that is one way you can think about it. All right, so now we're gonna, what we're gonna do now is you have this supplemental video on neutralization and pH and POH. You're gonna watch this video, and after watching the video, you are going to take notes in your note packet. So the next 2 slides will have those notes. All right, pause the video now, watch that other video, and take notes. When you press play again, the answer will be revealed. Okay, so here are what your video notes should look like. Take a moment to check your work. If you have any questions, bring those questions to class. For this one, determine the concentration of H+ and OH- from the Kw. We know that Kw is equal to concentration of H+ times OH-, and at 25 degrees Celsius, the Kw has is equal to the value of 1.0 times 10 to the minus 14. So if you set Kw equal to 1.0 times 10 to the minus 14, and you solve for both the concentration of H+ and OH-, since these two are equivalent, it'll be the square root of this value. And that's how we get these numbers. The center of the pH scale is at 7 because water is neutral, and the concentration of H+ in water, according to the Kw, is 1.0 times 10 to the minus 7. So the pH, being the negative log of that value, is going to be 7. pH plus POH is 14. And basically to solve, if you're given the pH and you want to solve for the POH, you just plug it into the equation and solve. So in this case, the POH would equal 1. All right, so that's it for part 1. Next video will be part 2.